All right, here we go. So first part of the review requires us to take what's called inequality notation and turn it into interval notation. The big thing here is realizing when to use negative infinity, when to use positive infinity, and when to use a rounded parenthesis or a square bracket. So what I like to do when I do this in my head at least is I like to think to myself, if I graph that inequality, what is that going to look like? Okay? So that's going to be a closed circle at 42, and then I'm going to shade to the left. Okay? What that means is I'm including everything from negative infinity up to 42, and since 42 is a closed circle, my interval notation would include a square bracket. Okay? On the second one, if I look at this interval on the number line, I'm going to have two circles, one at -3, one at +5. At -3 is going to be open, +5 is going to be closed. And we're only stating the interval in between, so it's only one piece. That interval runs from -3, which is not included, so it gets a rounded parenthesis, all the way to +5, which is included, so it gets a square bracket. So that would be our answer there. -3 to +5, -3 gets a regular parenthesis, 5 gets a square bracket. On the third one, it's a little bit different. We still have two circles, 0 and 3. 0 is open, but we shade to the left. And 3 is closed, and we shade to the right, which means we need to have two intervals joined by the AND function. The first piece will run from negative infinity up to 0 and does not include 0, so it gets a rounded parenthesis. And 3 is included, that goes up to positive infinity. Yeah. Okay, you're right, it would be the OR symbol. You are correct, that would be the OR symbol. Okay, so yeah, that would be the OR symbol, which is union, not intersection. Good call. Okay, I probably screwed that up on the on the completed ones I posted already too. So, OR is the U. Okay, this is the OR symbol. Remember, that means OR. This means AND. Okay, when we point out like that, that is an OR symbol. When we're between, it's the AND symbol if we need to combine different intervals. All right, good call, good catch. I'm glad you guys are in here with me because I would have screwed that up. Okay, on to the next section here. They're asking whether or not these relations are functions. So, with a table, with a mapping, with a list of ordered pairs, we are looking for, are any x values repeated? So on this first one, we look at the x column only. There are no repeats, so yes, that is a function. Since there are no x values relisted in the domain area of the table, that means that no x value is used twice, which means it is a function. Number 5 is a vertical line test. Simply put, if we can draw a vertical line anywhere that crosses that graph more than one time, that is a no because it fails the vertical line test. I think I wrote on the answers an extended explanation that means that x value, which I chose x equals 1, is related to two different y values. That is a problem. Okay, so the first one is a yes, second one is a no. That takes care of that section. On evaluating the function, the first two should be relatively straightforward. We're just plugging in that value for x. So f of -2 means that we use our f of x function, and we say -2 squared minus -2. So f of -2 would be 4 plus 2, or 6. That's your basic Algebra 2 function notation. The more advanced Algebra 2 version requires plugging in an expression instead of a number. It changes absolutely nothing. So for g of 3a plus 1, that means we are replacing the x in g of x with 3a plus 1, and then simplifying it as much as we can, which is not a whole lot. We distribute the 2. So g of 3a plus 1 is 6a plus 2 minus 3. And then we combine like terms, giving us our final answer that g of 3a plus 1 is 6a minus 1. 8 and 9 deal with a piecewise function. So here it's very, very important that you're finding the correct piece. The top piece is for any x value less than 1. The bottom piece is for any x value greater than 1. You should notice that means that 1 is not in the domain of this function. Okay? So if they asked us what is p of 1, which they do on number 9, x equals 1 is not in the domain. Which means there is no answer to that question. It is undefined. Okay? You could also say it doesn't exist with the empty set symbol. I would accept either one of those. You could also say no solution. I would accept that. Although undefined and empty set would be the better notational answers. For p of 5 is in piece 2. Okay, this is piece 1, this is piece 2. Come on, pen, do your job. P of 5, x equals 5, is in the domain for piece 2. So we would plug that into piece 2. P of 5 would be 4 minus 5. So p of 5 for that function would be negative 1. So that's to plug into the correct piece based on the x value. Okay? So I think that just leaves us with state, domain, and range left to do. Did I screw anything up, guys? Because you're all listening to me do this. Okay. Okay, I've never recorded with kids in the room before. All right. 10 is asking for the domain. When you're given an equation, you're basically trying to figure out what values are not in the domain. Okay? So when you have a rational fraction, this cannot equal 0. Okay, that's the problem. The denominator is not allowed to be 0 because division by 0 is undefined. So we would take whatever that denominator is, x squared plus 4x minus 5, and we need to know when it equals 0. We're really solving does not equal 0, but we treat it like an equal sign. And we solve for x. We need to figure out where it crosses the x-axis. So that would be a factoring problem. Factors of negative 5 that add to positive 4 would be positive 5 and negative 1, meaning that trinomial factors into x plus 5 and x minus 1. Then the zero factor theorem says that either the first factor does not equal 0 or the second factor does not equal 0. And don't get that or confused with the union symbol because that is not ever going to be used in this case. It'll always be the and symbol when we describe domain. Yeah. Okay, I need two numbers that multiply to negative 5. So your options are 1 and negative 5 or negative 1 and positive 5. And you need the set that adds to positive 4. That's this set. Okay? All right. So our two values that x is not allowed to be are going to be negative 5 and positive 1. Every other number is fine. So when you think about it in terms of being, if you graphed the solution for this, you would be graphing a number line with an open circle at negative 5 and an open circle at positive 1, and the rest of that number line would be shaded because every other value would be 100% fine. So when you write that domain, you have to write three different pieces, piece 1, piece 2, and piece 3, in interval notation with and symbols. So your first piece would go, this is piece 1 right here, piece 2, piece 3. Piece 1 would be from negative infinity to negative 5. Negative 5 is not included. Then every value between negative 5 and positive 1 is fine. So we'd say and negative 5 to 1. They're both rounded parentheses because those are both open circles. And starting at 1, we can go all the way to infinity, and the rest of those numbers are good. Okay? That's how we deal with holes in our domain. That's how he said he wants it done, the calc teacher, so that's what we're doing. Okay? The other one is significantly easier. Again, what we're looking for here is that this number underneath the root cannot be negative. Okay, so what we're doing with that is we're saying 3x minus 1 is at least 0. And we're solving that. Okay, now we've seen ones that are harder than this in our assignments, right? I wouldn't be shocked if one that's harder than this comes up on the test. If that square root were in the denominator of a fraction, we would just say greater than, not greater than or equal to. Okay? If you're solving this and you can't get a solution because you can't say, there's one on the homework where it's like 3 minus x squared or something, and you solve for x and you're trying to take the square root of a negative number, that means there's no restrictions. Okay? So we just got to watch that stuff. And I'm not sure, I'm going to look closer at the quiz, but I think more or less what we need to know is that we're just solving an inequality. Okay? We add 1, gives us 3x is at least 1, then we divide by 3, and we get x is at least 1/3. And again, we should think about that in terms of a number line. That means we would have a closed circle at 1/3, and we would shade to the right. Yeah? So when we write the interval notation, that would be from 1/3 all the way to positive infinity would be our domain. Okay, as for graphs, it's a little bit different. Remember that on a graph, and we've already talked about both domain and range, but only domain is on the quiz. Okay? The domain is everywhere the graph exists from left to right. So as we move from the graph, we look for where's the left end of the graph and where's the right end of the graph. If there's a hole, then we'll have to deal with it with multiple pieces like this. Okay? But on number 11, there are no holes. The whole graph is there all the way from x equals -3 all the way over to x equals +3. The graph does exist somewhere. So our domain for number 11 would simply be -3 to +3, including both values. Because every x value from -3 to +3, you could come up with a y value that is associated with it. On the second one, we're going to have 2 pieces for the domain, and by the way, it doesn't show arrows, which annoys me, but these 2 things do keep going up and out forever. So, we have 2 pieces. As we're moving from left to right on this graph, that graph exists everywhere until we hit the hole down here at x equals 1. So we really have 2 pieces that we need to write domains for, piece 1 and piece 2, the left side of the parabola and the right side of the parabola. And we have a hole there at x equals 1. So our first piece is going to run from -infinity up to x equals 1. So we would say -infinity to 1. 1 is not included in the domain. And then we would attach piece 2, which starts at 1 and goes to positive infinity. That is the entire review.